Hi, my name's Brooke Talbot, and I'm from Emory University. And I'm going to be sharing my work with you that is looking at the clonal transmission of methicillin-resistant Staphylococcus aureus among hospitalized adults, and these infections cause bloodstream infections. And what I want to talk to you about is how we use a genomic approach to understand the epidemiology of these bloodstream infections among these hospitalized patients. This was done as a collaboration between my home university and the University of Pennsylvania, where we work with the hospital to understand these particular infections. So what I've already spoiled in my poster is what we found, and that's patients with bloodstream infections that we looked at with these methicillin-resistant S. aureus, or MRSA, as I will refer to it, had evidence of clonal transmission and were likely spreading these infections between one another in some kind of network, either directly or indirectly, weeks to months before they actually exhibited any kind of blood symptoms. So how we did this was, as a part of our research, as a part of this study system, we had a routine collection of MRSA isolates from patients who are coming in with these infections. And we wanted to really understand what was going on with these infections. There's not too much that's been explored about bloodstream infections when it comes to transmission, because there's a general understanding that with a bloodstream infection, there shouldn't be much person-to-person direct transmission. Bloodstream isolates, blood-to-blood contact shouldn't be happening, and therefore it's usually an evolutionary dead end. But nevertheless, patients are still getting these infections, and it's important to understand when and how they might have been infected and what timeline and what might be those underlying causes. So we had 105 isolates from patients, and we wanted to understand if they clustered and if there were any clustering among the sequences, what might be some of those causes. And for some patients who were having multiple infections over the course of a year, whether or not those infections were related to one another, or if there might have been multiple introductions and multiple times that a patient was getting infected with MRSA. But as with epidemiological investigations, the other strategy that I wanted to take was understanding if we're going to be defining a cluster, if we're going to be defining transmission, we have to understand and try out a couple of different methods for how sequences would cluster in the first place. And that means taking an approach to look at how we're aligning our sequences together to understand if we're looking in a prospective way, whether or not we're getting all of the kind of we're capturing the genetic diversity or genetic similarity in this case that would show us where those clusters are. So in my work, I took 3 different approaches to alignment, one that uses a gene family approach, one that uses an assembly-based approach, and one that uses some of the just the core SNP approaches to look and compare different core genomes to one another to find which isolates were closely related and which ones we had clusters. So we started off our baseline with clusters being defined as less than 35 SNPs over the course of our 1-year period of investigation. And what we found was that when we take a gene family approach, we're finding that there's much more consistency across the genetic diversity, but much less than if you were to take a more reference-based approach with assemblies or with what I was calling a pseudo-read pipeline. And what we also notice is that with the more closely related isolates, the ones that were truly close to that 35 SNP threshold, or single nucleotide polymorphism threshold. Those that were close still remained quite close, even though we might have been losing a couple of SNPs here and there. And what we also found is that generally across these different pipelines, we were finding at least the same clusters themselves. though there was some patient dropout. So not everyone that clustered within one of these pathways always ended up clustering. There was some falling in and out depending on which method, but ultimately you were still finding generally the same location. So we had two major clonal complexes, or two major phylogenetic groupings for these isolates. Most of the clusters fell inside of CC8, CC5, and we had one cluster that was a CC30. But we decided that if we were going to take a look a little bit more at what was going on within each of these clusters, whether or not they had something in common in their lineage or if they had something common in their epidemiology, we broke out the trees a little bit more. And mostly we didn't find that there was anything particularly in common between clustering and non-clustering isolates, whether in terms of the hospital of admission for the bloodstream infection, or if they were initially being classified as a hospital-acquired association, a hospital-onset community-associated infection, or a community-associated infection. But what we did have information about was, among our clustering isolates, we had their hospitalization history over the year before their infection and the year after their infection. And what we found was, among 9 clusters that we identified that fell under this 35 SNP threshold, we had many clusters where there was overlap between the patients in the hospital system, many of those patients clustering in the same hospital itself, and some falling even in the same unit. But one thing that we definitely noticed was among these patients, among these clusters, many of them are going in and out of the hospital system to multiple different parts of the hospital, to multiple different hospitals within the system, in and out of the long-term care, into the more acute care units. And so they're in and out and possibly having multiple exposures, some of them overlapping multiple times with different patients. And when those overlaps are happening, we're not often or always seeing that those bloodstream isolates are close in time. This is most obvious in cluster 2, where you have 2 patients in this cluster where they both overlap in space and time in the same hospital unit, but it's nearly 2 or 3 months before either of them even had their bloodstream infection onset. What we also see in some of these patients is that there are some that have recurrent isolates. So there were 3 clusters that we looked at. And among the patients that had those recurring isolates, I mentioned that there are multiple times that patients could be coming into the hospital, but their initial bloodstream infection was the most closely related to their recurrent infection compared to any of the other clustered isolates alongside of them. So that means that these infections that they're having again and again are sticking around, and the patient is not clearing that infection. So what does all of this mean together? First, that when we start to apply a SNP threshold and we start to test that SNP threshold, there is some sensitivity to the method of alignment, particularly is what I looked at. So if we wanted to start, when we're starting with our clusters, and start with a broad-based investigation to try to find some commonalities, and then we can move into a more focused investigation of the phylogenetics to really understand which ones are going to fall in and out of the cluster to get some better information about the epidemiology. That would be an appropriate epidemiological approach. And then second of all, if we're thinking about an intervention for these patients, with MRSA, it's a bacteria that can colonize healthy adults, but those that may have predispositions that would weaken the immune system, or they might be coming in and becoming into a hospital system for various other kinds of care, that it might make sense to start to target this population if we can't screen everybody for MRSA, because then we might be able to intervene sooner before they actually get something like septicemia and having a poor outcome. We recently published these results in the Journal of Clinical Infectious Diseases, And if you're interested in finding out more or interested in following along with this work, including more work about the evolution of recurrence among these patients, then you can reach out to me at Emory University via email, or you can find me on Twitter at btalbs. And you can find out more about our work at Emory University at the Emergent group at this link. So thank you.